Okay, question number 16. R is proportional, so you can assume that means directly proportional to t squared. So that statement in itself means that you can set up the equation that says R equals K times t squared. That's what directly proportional means. K times, and then you've got the two letters that you were using in the sentence, okay? If you were to draw the graph, I've noticed that there's a nice point on this graph at 210. So what that means is when t is 2, r is 10, and I'm going to use that nice point in the equation here. When r is 10 and t is 2, I can calculate the k value. It comes out to be 2.5. Put that back in here, look, into the general equation, and you can find that the actual equation that works for our graph is going to be that r equals 2.5 t squared. In part B of the question, we're told that r equals 8 over 5x. So I've got an equation here that says r equals something, and I've got an equation here that says r equals something. So what I do is I put the two of them together, and so that means that 8 over 5x must be equal to 2.5 t squared. I do a bit of rearranging. I take the 2.5 underneath and divide by it. I get rid of the squaring by square rooting both sides. Now, a bit of manipulation going on in this underneath the square root symbol here. The square root of a fraction can be the square root of the top divided by the square root of the bottom. So the square root of 16 over the square root of 25. And if I recognize this x underneath as 1 over x, then you can split the square root signs like this. And then the square root of 16 over 25 is 4 over 5. And the simplified version of the square root of 1 over x is 1 over the square root of x. And here we have something that looks like it is inversely proportional. A number, 4 over 5, times by 1 over the square root. This is where the inverse bit comes in. It's 1 over. So this is showing that and proving that t is inversely proportional to the square root of x. T is inversely proportional to the square root of x.